Good morning students. Welcome you all for next generation learning. Today we are going to see the subject physics class 9 chapter number 9 force and laws of motion. Topics experiments based on the balanced and unbalanced forces, force and motion, frictional force, Newton's first law of motion, Newton's second law of motion. Before going to see the experiment, you have to know the concept. Balanced and unbalanced forces. Look at this image. They are playing tug of war. For in each team, there are the 3 members. And they applied the forces in the opposite direction with the same magnitude. 300 Newton, 300 Newton. So when the two forces acting in the opposite direction with equal magnitude, then the forces are said to be balanced force. In balanced force, there is no motion. In second diagram, they applied opposite forces with a different magnitude. The team 1 applied 300 Newton, the team 2 applied 400 Newton. So when the two forces acting in the opposite direction with unequal magnitude, then the forces are said to be unbalanced force. Now during unbalanced force, the object will move. So see the definition. If two individual forces, there are the two individual forces, or equal magnitude and opposite direction, then the forces are said to be balanced force. If two individual forces are of not equal magnitude and opposite direction, then the forces are said to be unbalanced force. The next topic is what is friction. The friction also one type of force. It occurs when the objects are contact with other object. So look at this image. This is a floor. The box is kept on this floor. So the bottom of the box is contact with surface of the floor. So here the two objects are contact with each other. So the frictional force occurs. The direction of the friction force is always opposite to the pushing force or applied force. If you applied the external force on this object, the frictional force is opposite to this applied force. But the motion of the object is always the same direction of the applied force. Do you understand what is meant by the frictional force? When the two objects are contact with each other, the frictional force occurs. And the frictional force is always opposite to the pushing force. Look at these 3 images. The two members applied a force on this box. In first diagram, this is applied force and this is a frictional force. And the value of the applied force and frictional force are same. So there is no movement in the box. And look at the second diagram. Here I applied, in first diagram if you applied the 50 Newton means the frictional force also 50 Newton. if I increase in the applied force 50 to 100 Newton. So when I increase in the applied force 50 to 100, the frictional force also increased to 50 to 100. So there is no movement in the box. In third one, the applied force is greater than the frictional force. So when the applied force is greater than the frictional force, the object will move. So in third case, the box will move. The next concept is Newton's first law of motion. You know that Newton's first law of motion? If a body at rest will remain at rest, and a body in motion will continue in motion in a straight line with uniform speed, unless it is compelled by the external force to change its state of rest or uniform motion. This is the statement of the first law of motion, and here the external force is nothing but the force from outside the body is called external force. On the first line, a body at rest will remain at rest unless it is compelled by an external force. So what is the meaning of this sentence? Look at this image. Here the object is placed on the table and the state of this object is rest. Unless applied the external force, the object does not change their position. So a body at rest will remain at rest unless it is compelled by the external force. The same thing, a body in motion will continue in motion unless it is compelled by an external force. Look this image. Here the boy is riding a bicycle. So here the bicycle in motion. So a body in motion will continue in motion unless it is compelled by the external force. But in one condition, if there is no frictional force, if there is no air resistance, means if there is no friction, there is no air resistance, means the body will continue in motion. Otherwise, it will stop after a certain time. If the friction force and air resistance are presence means after a some time the object will stop. So if there is no air resistance, there is no friction, means the object will continue in motion. This is the Newton's first law of motion. The next concept, Newton's second law of motion. The second law of motion states that the rate of change of momentum is directly proportional to the applied force. If the force is more, means the momentum of the object also more. If force is less, means the momentum of the object also less. So the momentum of the object, that means the motion of the object, is always directly proportional to the applied force. If you apply the more force, the object will move more fast. So the next we are going to see the live experiment about unbalanced and balanced forces under Newton's first law and second law. So look at this experiment. From this experiment I am going to explain balanced and unbalanced forces. So here there are the two teams. This is the first team and this is the second team. In each team there are the 4 members. 1, 2, 3, 4. The same as 1, 2, 3, 4. And this is the object kept at the center. And they given the 3 values, sum of the force, values and speed. So we can select all the things, values, speed. First, I choose one person from this team and see, this boy is applied 50 Newton force. It was clearly shown here 50 Newton force. So the sum of the force, in this side there is no force. For here he applied the 50 Newton. So the sum of the force is 50 Newton. 0 plus 50, so sum is 50 Newton. Now I switch on the go button. See the motion of this object. So who win this team? The red man win, because there is unbalanced force. Here there is no force, here the 50 Newton force. There is here 0 Newton and here 50 Newton. So unequal magnitude. When the unequal magnitude, then the forces are said to be unbalanced force. Again I come to written. Now I chosen the one more person for here. So for this side also 50 Newton and this side also 50 Newton. So the sum of the force is 0, because 50 minus 50 equal to 0. Now I press the button, go button, and see, there is no motion of this object. So when we applied the equal forces in equal forces, equal and opposite forces, then that type of forces are called balanced force. During the balanced force, there is no movement of the object. The next, I chosen the one more person here. Now see the force of this side, the 100 Newton. Here the only one person, so 50 Newton. So the sum of the force is 50 Newton. Now I press the button go. See, the object will move on the red side. So who win this? The red win, because in this side the more magnitude. Again I chosen one person from here. Now see, the both the sides are 100 Newton and 100 Newton. So sum of the force is 0. If the sum of the forces is 0, means the object does not move. Shall we check? Yes. See, there is no speed here, there is no movement here, because the sum of the force is 0. Now I add one more person here. Now can you say which team will win? Definitely the blue team will win, because the magnitude of this side is 200 Newton, here 100 Newton. So the sum of the forces is 100 Newton. 200 minus 100, 100. So the more force acting on this side. Shall we check? Yeah, the blue team win. The next, I add one more person here. For in both the sides, the magnitude is same. So the sum of the force is 0. If the sum of the forces is 0, means there is no moment. Check. So there is no moment because of the because of the balanced force. Again I add one more person here. Now check which team will win. Definitely the red team will win, because the sum of the forces is 150 Newton. Now I add one more person here. Now check it. Both the sides are same magnitude, 350 Newton, 350 Newton. So the sum of the forces is 0. So there is no moment. So during the balanced force, there is no moment in the object. When we applied the unbalanced force, the object will move in the greater magnitude side. Do you understand the concept about balanced and unbalanced force? Dear students, I will send the same link to you. You can also check it. This is the next experiment. For in this experiment, we are going to see the force is needed to move the object. So what are the things are given this experiment? The one man and some objects they given, the different objects they given, and here they given the Newton's value, and they given the value of the speed, mass and values. Now we will play. First we can choose the values, masses, speed. Okay. So see, when I touch the values, masses, when I touch the masses, here the 50 kilogram, 200 kilogram, 40, 80 and 100 kilogram appear. Speed, when I touch the speed here, the speed of the measuring of the speed meter will appear, and we can move this pointer. Now the position of this object is a rest. So how I can change the rest object to motion? When I applied force on this object, the object will move. How much force is required to move? Shall we check? Yes. See here. Here I touch this button. When I am touching this button, the value of the Newton will be changed. Look. 3 Newton, 4 Newton, 5 Newton. So now the object is started to moving. And see the speed also here, and see the Newton, the value of the applied force. And see, when I applied more forces, applied force is more, the speed of the object also increased. See the speedometer here, the speed of the object is move very fast. So here I given the 70 Newton of force to 50 kilogram of the object. So from this we can learn that the force is required to change the object. Now I took 100 kilogram of object. I apply a force. When I applied 1 Newton, there is no moment. 2 Newton, no moment. 3, 4, 5, 6, 7, 8. And when it reaches 9 Newton, the object is slightly started to move. 110 Newton, 11, 12, 13, 14, 15. So this is the direction of the force and this is the direction of the motion. The direction of the motion is always direction of the force. If we applied the more force, the object will move. Now see, the applied force is 365 and 400 Newton. So the speed of the object will increase more. We learn that F equal to ma. So if you apply the more force, the acceleration also more. If more mass means we have to apply the more force. We will discuss F equal to ma. Now I took only the 50 gram of object and I apply a force. The 50 gram of object. See, yeah, when it reaches 9 Newton, the object is start to move. The same thing, if I increasing the mass, you have to check how much force is needed to move. And it needs 10 and 11 newtons, then only it will move. So the force is directly proportional to ma. If mass is more means the force also need more. If you apply the more force, if you applied the more forces, the object will move very fast. See, the speed of the object will be increased. So the force is directly proportional to the A. So from this experiment we learn that the force is needed to change the object and force is directly proportional to m into A. If more mass means we need more force. If you are increasing the force, the acceleration also increased. The next experiment we are going to learn the frictional force. And look here, in this experiment they given some of the forces, values, mass, speed and friction. They given one more term, that is a friction. And also they given some object and we can change the applied force value. First I will select all the things. So when I touch the speed, the speedometer will appear. When I touch the mass of the object will shown and the sum of the forces are appear here. And here I chosen the point, the friction is in middle. When I move this, that is a none, we can increase the friction also, lot. So shall we start? Yes. Now I applied the force. This is a applied force direction. There are two terms that appear here. One is a frictional force and applied force. The frictional force is, this is applied force direction, this is a frictional force direction. So 1 Newton of applied force. See that when I am increasing the applied force, the frictional force also increased. See here, 90 Newton, 90 Newton. So see, there are the two arrow marks are appear here. The applied force is always, the frictional force is always opposite to the applied force. Now applied force value is 70, 72, 74, 77. Increasing the applied force. When the object will move, when the applied force is greater than the frictional force, then the object will move. See, sum of the forces is 0. Now see, the sum of the forces is 34 Newton. That means the applied force is greater than the frictional force. So the object is started to move. In which direction the object is moving? The direction of the applied force. After reaching a some time, it will stop due to the frictional force occur. So watch carefully. And see the speed of the object. Yeah. And see here, in after reaching is some time, the frictional force is higher than the applied force. See, this is the frictional force 94 Newton. There is no applied force here. So the object will stop after reaching a certain time. We will see. Yeah, now see that. Now the object will stop automatically because of the frictional. In a Newton's first law, I said that no, if there is no friction, there is no air resistance, means the moving object will continue in motion. But if there is a friction and there is air resistance, means the moving object definitely it will stop after some time. So it was clearly shown here. The next we will try in the opposite force. If maybe the force is applied in this direction, here this is the force direction, so the frictional forces occur in the opposite direction. So I am applying the force in the opposite direction. You have to press this button. So see the Newton, the sum of the forces is 0, there is no moment. When the applied force is greater than the frictional force, the object will start to move. Here the both the forces are equal magnitude, so there is no momentum in the object. Now see, now the applied force is greater than the frictional force, so the object move in this direction. So the sum of the forces is 46 Newton. After reaching sometimes the applied force is going to 0 and the frictional force is more than the applied force. We will see. Wait. See the speed of the object and see the speed of the object here. After reaching in a particular distance, the applied force, the force of the strength of the applied force is reduced. Yeah, now see. Wait. Definitely it will stop after some time because the frictional force is 94 Newton here, there is no applied force. So due to the frictional force, the object stopped. So now do you understand what is the importance of the frictional force? The frictional force always stop the moving object. If there is no frictional force, means the moving object does not stop. If maybe the lot of friction, we will select here. See this button, here I selected the lot of friction. Okay, we will start. The friction is lot. The frictional is lot means we need to apply the more force. Now the frictional force is 172 Newton. The speed of the object will come to rest for very fast. Yeah. If there is no friction, we will select here. There is no friction. If there is no friction means, see the floor, it is very smooth. If there is no friction means the object will continue to move. Shall we check? Yes. See, here there is no frictional forces arises because the surface of this is smooth, so there is no frictional force. So here see the arrow mark, the only one side it shows the arrow mark, that means applied force, the applied force only occur here. There is no frictional force because of the smooth surface. And see the object will continue to motion. the the object does not stop. So if there is no frictional means the moving object will continue in motion. It takes more time to stop, and also it does not stop because there is no friction. See the object are continuous in motion. So the next one is acceleration. The next part is acceleration. See here, sum of the force, value, mass, speed, acceleration, and they given friction also. The same objects are, some objects are given. We will select all the things. Sum of the force, values, mass, speed, and acceleration. And here we will choose some other object. Here I chosen this object. We will choose this and this. Now I applied the force. See, there are the two forces are occur. One is applied force and another one is a frictional force, because here I selected the frictional. So the more force is needed to move this object, because the weight of the object is a 240 kilogram. The applied force and the frictional forces are equal value, so there is no movement in this object. It reached 190, I think so, 200. We will wait. So we will reduce the weight. The applied force and the frictional forces are equal in value, so there is no movement in the object. So the 500 Newton is not enough to move for the 200 kilogram of the object. So we will choose some other object. We will choose only the 40 gram girl. And everything we will choose here. Okay, if I applied the force. Yeah. Now see, the applied force is greater than the frictional force, so the object is moving, and see the value of the speed and acceleration here. The acceleration is 1.5 meter per second square. The speed is continuously changing. And after reaching a certain distance, the applied force value is decreased and frictional force value is increased. So the object move in opposite direction. See the speedometer and acceleration values here. Yeah. See, when the object move in opposite direction, in this direction, the acceleration will be in negative direction, minus 1.88 meter per second. Yeah, after reaching some time, the object will stop due to the frictional force. Shall we check some other object? Please listen very carefully. We will take some other object to check the acceleration in positive direction and also negative direction. We will choose the 100 kilogram of this. I am applying the force on this bucket. Here the applied force and frictional forces are in equal value, so there is no movement in this object. When the applied force value is greater than the frictional force, the object is started to move. Nearly, I think so, 300 Newton needs to move this object, because mass more means the force also need to move. Now see the direction of the speedometer and acceleration value. The acceleration is 0.72 meter per second and the applied force is greater than the frictional force. After reaching a certain distance, the applied force will go to 0. Due to that, the frictional force value will increase. And see the speedometer and acceleration. The acceleration value is decreased, 0.72 meter per second square. Yeah, now watch carefully. Yeah, here the acceleration is in negative direction. That means the object is moving in the opposite direction of the applied force. It shows that the acceleration is decreased and the acceleration goes to for 0. If the speed is 0 means the acceleration reach 0. See, the acceleration reach 0. So from this we can learn that F equal to ma. If more force means more acceleration. If more mass means we need to give more mass. And after reaching certain distance, the speed of the object will be reduced. It indicates that the object acceleration is reduced. Dear students, I hope you understood how to do these experiments. I will send the link to you. You can also try it. If you have any doubt, you can ask through teachment. Through teachment, I will show in the live. Thank you for watching. Thank you all.